Okay, here's the example that we're trying. The integral of x times cosine 5x dx. So, first of all, you notice that there's a function multiplying a function. We have seen those in u substitution problems before, but this time there's no way to pick out an inside function, take its derivative, and see it on the outside. For instance, if you pick out 5x, the derivative is 5, which does not work out very well when trying a u sub. So when you can't do u sub, but you are looking at two functions multiplied, then maybe you should try reversing the product rule, which is another way of saying integration by parts. So the first thing you do is you pretend that it is a product rule, or at least part of a product rule. So the first half, so you identify a function, copy of a function u, and a derivative of a function dv as the two factors of the original integral. So a good idea, if you can, is to choose the function u to be something that has a simpler derivative than what you see originally. That way the problem will get easier as you go. So I went u equal x because when I take the derivative I get 1 dx. I'll move the dx over just like in u sub. And then dv is everything else. So that's cosine 5x dx. So I'm saying that's a derivative of something. I need to find out what the original function was, but it's an easy antiderivative. The antiderivative of cosine 5x dx is cosine goes to sine, since I'm doing antiderivative, and then because of the 5x I have to multiply by 1/5. Double check that by taking the derivative going backwards. You get 1/5 times cosine 5x times 5, and the 5 times 1/5 cancel out. So that's the basic work that needs to be done to get started. And now I do a substitution step so that I can solve the rest of the problem. Alright, so I use this formula. My original problem is u dv, the integral of u times dv. And the answer turns out to be u times v minus the integral of v times du. So that's the answer is the two original functions that we did the product rule on, I guess, in order to get the problem, minus the missing mismatch of the two functions, the copy of v and the derivative of u. So that's my answer, although it's not finished. It's an answer in progress because I need to finish that last integral. So here's the problem, x cosine 5x dx. I found u and I found v, so I multiply those together, x times 1/5 sine 5x. Then I subtract v times du, and that's the 1/5 sine 5x, and my du was just 1 dx. So I just get to put the dx on there. Now I can finish it. That's step 4. So I just keep the x times 1/5 sine 5x, and I do the antiderivative of that sine 5x. I have to be careful with the minuses because there's a negative from the original formula. I pulled out a -1. I pulled out a 1/5. Then the antiderivative of sine is negative cosine, because the derivative of sine is cosine, so the antiderivative of sine is negative cosine. And I have to multiply by 1/5 again because that was sine 5x. So I get negative 1/5 times negative 1/5 cosine 5x, which you can simplify. Double negative is plus 1/25 cosine 5x. And I wrote x times 1/5 as x over 5. And plus c.